Hello, Algebra 2. This is Lesson 100, Graphs of Parabolas. Start off by first looking at some of the illustrations at the beginning of your Lesson 100 notes. You'll recall that a quadratic written in this general form, ax squared plus bx plus c, is going to create the graph of a parabola. And sometimes we are able to figure out the vertex of that parabola, that's the tip of the parabola, by using a shortcut method called x equals negative b over 2a. All right, so we have learned that in the past, and we've made xy tables, started that in Algebra 1. We're going to quickly look at some of the things that are happening with our parabola. We can have vertical shifts and horizontal shifts. When we have a vertical shift, okay, where we have the parabola has been either shifted up or down, that is affected by a number outside parentheses at the end. When we shift left or right, that's affected by the number inside the parentheses, added or subtracted. And then we can have basically dilations of that parabola getting skinnier or fatter. And then we can also reflect that parabola down by having a negative out front. Okay, so these are just some of the things that you'll come across. Probably the most important thing for your lesson today, though, is to remember how we do completing the square. So I'm going to first go to my star 1 and dive into our favorite questions, completing the square. This one is set up different than any completing the square you've had before because we actually have a y on one side and then all of the x on the other. So I'm going to show you how we change things so that we can keep that y on the left side. Okay, so I'm going to, first of all, bring down my original equation and know that when I do completing the square, I focus in on just these first two parts, but I have a magic box that I add to it. And the plus 2 has to still remain part of it. And then for the second part, I have to subtract that magic box in order for it to even out, to cancel with each other. I had one that was a plus box and one that's a minus box. And then please recall how we get that magic number inside the magic box. We take our b value and divide it by 2, and then we square that. So our b value is the number that's in front of the just x. In this case, it's negative 4. We divide that by 2, we get negative 2. And we square it, we get a positive 2. So when I go back, or excuse me, we get a positive 4. When I go back for my magic value here, negative 2 squared, and that's going to become 4. And I make sure that my magic box, that same number, gets subtracted outside. All right. And then rewriting what's inside the parentheses factored is where we take the first number square rooted and the magic number square rooted and bring down the minus in the middle. And then outside I have a plus 2 minus 4. That means it's going to be a minus 2. Oops, and I forgot to put my squared there. Okay, now it is written in what's called vertex form. And the reason it's called vertex form is the numbers lend us to the vertex very quickly. The x value is always going to be the opposite of whatever is written. And the y value is the same of whatever is written on the outside of the parentheses. So in this case, my vertex is going to be a positive 2, because it's the opposite of that negative 2. The y value is going to be a negative 2, because it's the same as the outside value. Once I know my vertex, I can then make my xy table. I take the vertex value and I plug that into the middle of my xy table. And then I'm just going to go up and down from that x value of 2. If I go smaller, I get 1 and 0. If I go bigger, I get 3 and 4. I'm going to take those numbers and plug them back in. Probably I'll plug them into the original equation. That's easier usually. So I take 0 and I plug that into the original equation that's highlighted. 0 squared minus 4 times 0 plus 2. That just gives me a positive 2. I take 1 and do that same thing. 1 squared minus 4 times 1 plus 2. That gives me a negative 1. Follow suit with 3 and 4, plugging 3 in. 3 squared minus 4 times 3 plus 2, and I get negative 1. Plugging 4 into that yellow highlighted equation, 4 squared minus 4 times 4 plus 2, and I get 2. And what you should notice is that these numbers reflect each other if you did it correctly. Okay, so now I'm going to go over and graph what I have. The vertex is at 2, negative 2, so I'll put a dot there. And then I'm going to go from there to each of the sides. I have 0, 2, 1, negative 1. I also have 3, negative 1, and 4, 2. You can start to see where that parabola is now developing. It curves. It's not a point, but it curves down there at the vertex. Okay, so there's my sketch of the parabola. All right, we're going to try star 2. Using that same method, we're going to do completing the square. Now this one's a little trickier because there's a negative out in front of the x squared. So I'm going to go ahead and pull a negative out from the first two terms. When I do that, it becomes x squared plus 8x. And I'm going to leave minus 10 alone. Okay, now I'm going to introduce the magic box for the completing the square. So inside the parentheses, I add a magic box. Outside the parentheses, I would normally subtract that magic box. However, I have a negative out in front. So that means the first box actually is getting subtracted when you distribute that negative. So the second box here has to be added in order to cancel it. All right, and then remember what method we used up here to figure out what goes inside that magic box. We find our b value, divide it by 2, and square it. So the b value is a positive 8. Okay, so positive 8 divided by 2, that would be 4, and then square it would be 16. So I'm going to add a 16 for that magic box. Outside, remember it's an add because the first one's going to have a negative distributed. So I add 16. Now I'm ready to factor inside the parentheses. Keep the negative out front. Take the square root of the first term and the square root of the second term, or the last term, and then pull down the sign from the middle term. So x plus 4, and then we can't forget our squared. Outside I have a negative 10 and a plus 16. When I combine those, I get a plus 6. Okay, so once again, I'm in what's called vertex form. I take my x value and change the sign to be the opposite. I take my y value and keep it the same. So my vertex on this one, changing my sign, is going to become negative 4. Keeping my sign on the y, 6. And then I'm going to go ahead and make an XY table to figure out how the rest of it looks. Okay, the middle of my XY table, I'll put my vertex, which was negative 4, 6. And then I'm going to go up and down from that -4. So if I want smaller, I'd go more in the negatives, -5, -6. If I go bigger, I have -3 and -2. And then remember, it's a lot easier at times to plug it back into this original equation, and please feel free to use a calculator to help you with that. Just watch, because these are all negatives getting plugged in, so when you go to square it, it does need parenthesized. All right, so plugging in a -6, squaring it, and then having a negative still out in front. -8 times -6, -10. Again, use that calculator to help you. What I got was 2. When I plug in a -5 to the highlighted equation, I get a 5. When I plug in -3, I get a 5. And when I plug in -2, I get a +2. Okay, so I'm ready to graph this. The vertex is at -4, 6. That's over here in quadrant 2. And then if I plot the other points, I have a -5, +5, a -4, or excuse me, a -6, +2. I also have a -3, +5, and a -2, +2. You'll notice this parabola looks like it's going to a frowning position. It's opening down. And the one thing that could clue me into that at the beginning is that it had a negative out front. I also saw that in the vertex form, and that tells me that it's going to be a frowning parabola. All right, that's it for our star questions. Let's move on to question A. This is from your textbook, page 418. Complete the square as an aid in graphing. Y equals x squared minus 2x plus 3. So to graph this, I need to figure out vertex form. That means I'm going to start off separating these first two terms and then have plus a magic box. The plus 3 is on the outside, and then I need to subtract that magic box in order for it to cancel. Finding that magic box, I take the b value, divide it by 2. So -2 divided by 2 is -1. And then square that, I get +1. Put that same thing in the magic box that's being subtracted outside. All right, then I go back to taking this first term, square rooting it, the last term, square rooted, bring down the symbol, then minus for the middle. The outside, I have a +3 and a -1, so that's going to become +2. Okay, so that's vertex form. The first x value here becomes the opposite. So it's a -1 as it is, so I change it to +1. And the y value stays the same. So my vertex is at 1, 2. I'm going to go ahead and make my xy table. And I know that my vertex has to go in the middle. So 1, 2 goes in the middle. And then I'm going to go smaller and bigger from there. So if I go smaller, I count down to 0 and -1. Bigger, it's going up to 2 and 3. Probably taking that original equation and plugging in the values is going to be the most helpful. So plugging in a -1 into the x squared minus 2x plus 3, I get a +6. Plugging in 0, that's a little easier. That zeros everybody except for the 3. When I plug in 2, I should get that same answer, 3. And when I plug in 3, I get a 6. Okay, now I'm ready to graph what I have. So -1, 6, 0, 3, 1, 2, 2, 3, and 3, 6. And it takes on the slight look of a parabola, Just make sure we try to curve it there, not point at the vertex. Okay, and then we have one more practice question together. This is question B from textbook page 418. The original equation is y equals negative x squared minus 4x minus 3. First thing I need to do is pull that negative out of the first two terms. So I just factor a negative out front, but it does not impact my minus 3. Next, I'm going to do the magic boxes to complete the square. So inside, I add a magic box. But remember that it's actually being subtracted. So if I subtract a magic box, that means out here, I have to add it in order for it to cancel. Okay, and then that magic box is to take that b value and divide it by 2 and square it. So 4 divided by 2 is 2, squared is 4. That means inside the magic boxes, I'll put a positive 4. All right, and then I go back to rewrite it factored form. First number square rooted, sign from the middle number, last number square rooted, and then outside a minus 3 plus 4 becomes a plus 1. Vertex form, I take the opposite of the x, so that's now negative 2. Take the y as it is, I get negative 2 comma 1. Making my xy table. Oops. My vertex in the middle. And then I am going to go smaller and bigger from there. And I'm going to key in on the original equation and plug in those values. So plug in a negative 4, I get negative 3. Plug in a negative 3, I get 0. Negative 1, I get 0. When I plug in 0, I get negative 3. Okay, I'm going to go over and graph those points. Oops. Negative 3, comma 0. Negative 2, comma 1. Negative 1, comma 0, and 0, comma negative 3. And it looks like our parabola is opening downwards, which we knew. It had a negative out front. And there's my solution. All right, your homework on lesson 100 is on Delta Math. Good luck.